Welcome back. This is part 2 of section 1.1 on graphs. So one thing really briefly is that line graphs can be used to illustrate relationships between variables, for instance, in real life, in science, in all sorts of fields, in everyday. So like in newspapers and things, we'll be able to see graphs. So for instance, here's just a couple of graphs. We've got the snow in inches plotted against time, and maybe this is time in days. And based on the shape of the graph, we can begin to understand what was happening. Or the information given in these graphs. So for instance, here this graph is going steadily up. It's increasing the whole time. So when we look at this, we might think, okay, so it was snowing at a constant rate the whole time. It never snowed heavier or stopped snowing. The snow didn't melt. It all just increased at the same rate over time. Whereas this one, we can see that, say, the snow fell really rapidly. It was very steep and it went very high very quickly. But then there's a flat period where it wasn't snowing at all and the snow stayed around, and then maybe the snow started to melt afterwards. So we can tell all this just from the shape of the graph, and we can do even better if we have more specific information. So if we start labeling some of the axes with actual numbers, we can answer very specific questions. So for instance, maybe at day 1 after the snow started falling, we could ask how many inches were there. Well, 1, 2, 3, 4, 5, 6. So in day 1, according to this graph, there were 6 inches, and this is, say, four days later, there were still 6 inches of snow, but maybe on what is this, day 1, 2, 3, 4, 5, 6. But on the 7th day, there was only about 3 inches of snow left. So being able to look up the time specifically, and then we can come over and actually see exactly how much snow there was. Sometimes we'll have to be a little bit careful because, so for instance, the number 7, this doesn't really refer to a particular day. Is it the 7th of November? Is it the 7th day of the year? So when you're looking at a graph, you have to be careful that you really understand what this is saying. So maybe this is time after, so time in days, after a particular day, maybe after December 1st, or something of this nature. So you do have to pay a little bit of attention and really understand what do the numbers mean. Number 7 as a day doesn't really make sense. And along the same line, we can come up with equations based on words, and this is something that we'll do a little bit this semester, but this is very important sort of outside of the classroom. So for instance, first example, we're going to take a taxi, and the fare is going to be 15 cents per mile plus a $9 flat fee. So it would be nice if we could come up with some way to know exactly how much we'll have to pay after we take the taxi, and at 15 cents per mile, we can go, okay, so 15 cents per mile, this will mean that we'll take that 15 cents and we'll take it times the number of miles that we have to go. So we'll just use m to represent the number of miles. This will be a variable, plus a $9 flat fee. So at the end of the day, we'll also have to pay another $9 on top of the mileage, and this is going to be the fare for the taxi. So maybe we can call the fare for the taxi F. And this is basically just coming up with an equation to give us some more information. Now, granted, this would be a fairly simple calculation, but many equations will be a lot more complicated than this, and it'll be useful to know the exact equation in some instances. And these can be described in many different ways. The previous question was fairly straightforward and used language that we're familiar with, but it could be something a little bit different. So, for instance, this says the y value is 6 decreased by 5 times the square of 6. This is not how we would speak normally, I would say, but we can interpret this. So when this says the y value is something, this means that y is going to be equal to something. If we say that two numbers, if we say that one number is another number, it means that they're equal. So the y value is, and then it'll be 6 decreased by something else. So we're going to take 6 and we're going to decrease it. We're going to subtract something from 6. And then the rest of this should be fairly straightforward. 5 times the square of x. 5 times the square of x. So this is just 5 times x squared. So we can interpret words and as numbers. And this is something that's very important, say in physics and chemistry, but also in all sorts of areas. Being able to interpret words as numbers, and being able to write equations for those. Eventually, we'll be able to draw graphs according to these equations and really analyze exactly what's going on.